Once again, good evening to all of you. Welcome back to another session on this control system subject topics, in which we are looking after the signal flow graph method of finding the transfer function of a given signal flow graph. Okay, in today's presentation also I would like to explain you one more example on signal flow graph method, that is how to find out the transfer function. Okay, so let us go to the presentation. So it is your lecture number, it is your lecture number 10. So here in this presentation I would like to explain one example. Let us see the given signal flow graph. So in the given signal flow graph you have normally 6 nodes. I will draw for first node, second node, third, fourth, fifth, and then our sixth. This is your R of S, this is your C of S. Identify as node 1, node 2, node 3, node 4, node 5, and then node 6. And it is given that between node 1 to node 2 the gain is given as G1, between 2 to 3 it is given as gain G2, between 3 to 4 the gain is given as G3, and 4 to 5 it is G4, and then 5 to 6 it is given as G5. Forward gains, these are nothing but the forward gains. And between 2 to 3, between the nodes 2 to 3 you have feedback loop as the gain as H1, and then between 3 to 4 you have H2, between 4 to 5 you have H3, and then you have 3 to 5, between node 3 to node 5 you have one forward path of gain G6. This is the given signal flow graph diagram. For this you are asking to find out the transfer function. You are asking to find out the transfer function, that is nothing but C of S by your R of S. C of S by your R of S. This is what you need to find out. Well, let us see the steps. Let us apply the steps which we have seen in our last presentation, right? So now I will go to the solution of this. Okay, I will solve this solution. So this is what the given signal flow graph, and this is your input R of S, and then this is your output C of S, and here there are gains, different gains are given, means 1 to 2 the gain is G1, 2 to 3 means the node points it is G2, 3 to 4 the gain is G3, 4 to 5 it is G4, 5 to 6 it is G5. All these are the gains of that particular path which is available in that particular node. And similarly, secondly, if you see, there is a a reverse path, nothing but it is a feedback loop. It is a feedback loop, okay, with gain h1. This is another feedback loop with gain h2. This is another feedback loop with gain h3. Is it not? Now let us directly apply the steps which you have seen in our previous presentations. Now I apply step number 1 of your signal flow graph technique. What is the step number 1? Your step number 1 is nothing but number of forward paths. Number of forward paths with their path gains. With their path gains. That is what your step number 1. Number of forward paths which are available in the given signal flow graph. Okay, then consider the first path which is available between R of S to your C of S. If you see now, so there is a direct path G1, G2, G3, G4, G5. This is the straightforward path available from R of S to C of S because all the arrow marks are directed towards C of S. Starting from R of S and they are going forward, and that means that they are reaching to C of S. That is nothing but your first forward path. So your first forward path, nothing but P1, P1, P1. Consider that as path 1, P1. So then this is the first forward path. What are the path gain? Path gain is nothing but, as we have seen in previous example, you multiply all the gains available on that path. It is simply G1 into G2 into G3 into G4 into G5. That's all. That means it is G1 into G2, G3, G4, G5. Just to multiply all the gains which are available on that path. That gives your first forward path with corresponding path gains. This is your first forward path. Okay. Other than this, is there any other forward paths available in the signal flow graph? Right. If you see in the signal flow graph, from this point or from node 1 to node 2, from node to 3, and from 3, if from node 3, so there is a forward direction arrow mark shown towards forward direction and it is going towards CS. Means there is another forward path is available in the signal flow graph. Means nothing but it is your second forward path. What is that path? It is like this. Starting from node 1 means that 1, 2, 3 and going to 5 and then reaching to 6. What are the gains available on this path? G1 into G2 into G6 into G5. Understood? Because here the forward path, the arrow mark is directed towards forward direction only. Therefore, this is another forward path. This is the straight forward path which we have considered as path 1. And secondly, again start from the first one. From first one, it is coming like this and going in this direction and going towards C of S. That this path you should consider as your P2. Means that, so there is another forward path available with path gain. What is the path gain? G1 into G2 means G1 into G2 into G6 into G5. That's all. That is the second forward path which is available for the given signal flow graph. There are two forward paths. Is there any forward paths other than these two? So, as far as this problem is concerned, there is no other forward path because there is no other path which is shown the arrow mark in the forward direction? No. Therefore, you don't have any other forward path other than these two. So, these two are the forward paths with corresponding path gains available in this given signal flow graph. That is what your step 1. That completes your step number 1. Step number 1. Now, what is step number 2? Let us see. See, as simple as it is. Now, what is step number 2? What is step number 2? In step number 2, we have to find out the individual loops with their loop gains, which are available in the given signal flow graph. The number of individual loops that are available in the signal flow graph. So you have to identify the individual loops and you have to write down the loop gain, the individual loop gain. So let us see here, from if you see this signal flow graph, from node 2 to node 3 there is a forward path, there is an arrow mark given with forward direction, and from 3 to 2 again it is coming back with the reverse arrow mark, means reverse path, means that here it is a loop. This is loop 1. You can call it as your loop 1, because starting from 2 going forward up to 3, from 3 to 2 again coming back, means it is your loop 1. Loop 1 means in step number 2, number of individual loops, number of individual loops with their loop gains, with their loop gains. You have to write down individual loops are identified by the letter L suffix 1, L suffix 2, L suffix 3 and so on and so forth. So how many individual loops are there? This is one individual loop. So those are L1, the first loop. L1, what is the first loop? It is this one. So then what is the gain? So the gain which are available on that path shall be multiplied. That is nothing but G2 multiplied by H1, means G2 into H1. That is loop gain for the first individual loop. This is the loop gain for the first individual loop. And similarly, is there any other loop? L2. Obviously, if you see the second one, from 3 to 4, means from node 3 to node 4, there is a forward direction with gain G3 and it is coming backward direction with gain H2. So then what is the gain here? G3 into H2. G3 into H2. Therefore, the second individual loop is G3 into H2. That is the second loop. This is your loop 1. This is your loop 2. This is your loop 3. And the loop 3 is equal to, loop 3 means that this one. This is 1. This is your loop 1. This is your loop 2. Likewise, this is your loop 3. Understood? So G4 into H3. G4 into H3. Okay? G4 into H3. Similarly, there are 3 loops. Is there any other loop available other than these 3? Is there any other loop? Means, again if you see from node 3, see that the arrow mark is given towards forward direction up to node 5. From node 5, it is coming backward direction to this node. From this node again it is going to forward and finally it is ending to here. Means that from 3 to 5, this is one arrow mark is going forward. From 5 to 4 and 4 to 3, means that this is forming another loop here. Means the loop is starting from this point and going in this direction and here and here. Okay. Therefore, this is nothing but another individual loop. Then what is the gain? That is nothing but you consider that as L4. L4 is equal to, what is the gain? Then from 3 to 5, what is the, it is G6 into, and 5 to 4, what is the gain? It is H3. Don't confuse, G4, G3 will not come in this, because our path is like this only, from 5 to 4, then H3 will come, and 4 to 3, node 3, gain H2 will come. That means G6 multiplied by H3, and then the total is multiplied by H2 into H2. That's all. G6, H3, H2. That's all. That is your L4. That is the fourth individual loop with the loop gain this much. So, in this given signal flow graph, there are 4 individual loops. This is loop 1, loop 2, loop 3, and this is loop 4. Bigger one. It is loop 4. It is loop. Okay. Then, other than these 4 loops, is there any other loop? No. There are no other loops available in this. Therefore, with this, your step number 2 is over. Now, coming to step number 3. Coming to step number 3. Okay. Coming to your step number 3. What is step number 3? Identifying the number of 2 non-touching loops as well as 3 non-touching loops. Is it not? So, step number 3. In step number 3, what we have to say? 2 non-touching loops. Is there any possibility of 2 non-touching loops and 3 non-touching loops? Is it not? Is there any possibility of availability of 2 non-touching loops? What? 2 non-touching loops and 3 non-touching loops are available in the given signal flow graph. If at all, then we have to identify them, and we have to mention the loop gain. So here, say for example, let us see the first one, 2 non-touching loops. 2 non-touching loops means you have to find out 2 individual loops, and those 2 loops should not touch to each other. That is the meaning of it. Okay. For this concept, say for example, how to identify? Let us consider the first loop, means 2 to 3, this one, this is your loop 1. And if you consider the second loop, these 2 are touching. Therefore, these 2 loops should not be considered for this case. Means you should have 2 individual loops, means 2 separate individual loops, and those 2 loops should not to touch each other. Understood? Means take the first loop, and if you consider the second loop, it is touching to this first one. Therefore, you should not consider this, and consider the third loop. Means that if you consider the first loop and consider the third loop, means these 2 loops are not touching to each other. Means how many? Loop 1 and loop 2. Therefore, 2 non-touching loops are there. Likewise, you have to identify. This is one loop. The third one is the another loop. Okay, jointly that is nothing but 2 individual loops you are having here. Loop 1, loop 2, and these 2 are not touching to each other. So then what we have to write for this? So you can write that the first combination of, means the first possible combination of, you can write like this, the first possible combination of 2 non-touching loops. What? 2 non-touching loops that you can identify, you can represent as L suffix 1 1. L11, that is the representation. Okay, so forward paths are identified P1, P2, P3, P4, P5, P6, and so on and so forth, and that is as per step number 1. And as per step number 2, the individual loops are identified by the letter L1, L2, L3, L4, L5 and so on and so forth. And coming to step number 3, 2 non-touching loops, 3 non-touching loops, they are identified L11, L12, L13 and so on and so forth. Therefore, in this case, so the first possible combination of 2 non-touching loop is nothing but, so this is loop 1, L1 and L3, that is nothing but you can write L1 into L3, very simple. So this is equal to, what is the gain of L1 means, what we have to write here, identify the loop, take the loop gain of each individual loops and take the product. That is the meaning of it. Therefore, that's why L1 into L3. This is what we have to consider. Therefore, what is the L1? Loop gain you have to write G2H1. That means G2H1 loop gain of L1 into nothing but product. What is L3? Gain of L3? G4 into your H3. This is what your L11. That is the first possible combination of 2 non-touching loop. Therefore, for 2 non-touching loop, you have to take the gain product of those 2 non-touching loops. You have to consider the gain product. This is the gain of first loop. This is the gain of the second loop. And this is what the total, that is nothing but G2H1, G4H3. That is what the first possible combination of 2 non-touching loop. Okay, that is the first possible combination. Other than this, is there any possible combination of 2 non-touching loops? Let us see. If you consider these 2 should not be considered, these 2 also should not be considered because touching to each other. Again, these 2 are touching to each other. And again, this is a third loop actually. This is what the third loop. And this third loop is touching to this loop and then this loop also. Means this is a bigger loop, no? So this bigger loop is touching to this internal loop here, these 2 points. This one is touching this loop L3 here. And similarly, this bigger one nothing but your L4. This is what your L4. L4 is touching to L3 and L2. Even this L4, this is what your L4 actually. Your L4 is touching to L1 here. Therefore, there is no other possible combination of 2 non-touching loops. We have only one possible combination of 2 non-touching loop. Understood? Very good. Then coming to the third one, I mean the next one, what is that? 3 non-touching loops. 3 non-touching loops. 3 non-touching loops. Okay. This means that in the given signal flow graph diagram, you must have 3 independent, 3 separate individual loops, and these 3 loops should not to touch to each other. So, how many loops actually you have in the given problem? You have 4 loops. In fact, 4 loops are touching. So, as far as 3 non-touching is concerned, loop 1, loop 2, loop 3, however, these 3 are touching to each other. And again, these 3 are collectively, jointly touching to the 4. Where is the possible combination of 3 non-touching loops? Therefore, you don't have any possible combination of 3 non-touching loops in the given problem. Therefore, you don't have anything for this. Means this particular is not applicable to this. You have this much only. This is what your step number 3. I think you all are following this. And now, coming to the step number 4. This is your final step. And for this final step, you are not required to consider this because now I arrange for this block, I erase this diagram. So now the step number 4 is nothing but directly it is the calculation of, it is step number 4. It is nothing but it is directly calculating of the transfer function. In this, as per the Mason's gain transfer formula, transfer function is equal to, we have seen that 1 by delta sigma sum k is equal to 1 to n it is P suffix K and then delta suffix K. This is what your formula. Okay, this is what your formula. This implies if you expand this, transfer function is equal to 1 by delta, if you write. So here K is nothing but your number of forward paths. Okay, so how many forward paths are there? 2 forward paths. Nothing but K value is 2, means 1 to 2. Okay, here you can say 1 to 2 you can write for the given problem. This is general. It is for the given problem, it is 1 to 2. That means that if you substitute K is equal to 1 to 2 in the given expression, then you will have P1 delta 1 plus P2 delta 2. Why? Because the summation is nothing but like this only. It will be expanded like this only. Summation is nothing but sigma is nothing but sum only. P1 delta 1 plus P2 delta 2 plus P3 delta 3 if 3 are there. Likewise. Okay, then this implies furtherly 1 by delta. Okay, what is P1 here? P1 you already know, that is the first forward path with its path gain, that is nothing but G1, G2, G3, G4 and then G5, is it not? G1, G2, G3, G4, G5, that is what your P1. Okay, what is the delta 1? Delta 1 is nothing but, okay, I think you may have little bit confused here, but very clearly you should listen here. Delta 1 is nothing but, how to find out the value of delta 1? Delta 1 is nothing but, see the problem, I mean given signal flow graph diagram, and consider the first forward path. So for the given or for the available forward path or first forward path, for the first forward path, in the available loops, is there any loop which is not touching to the first forward path? There are 4 loops are available in the signal flow graph. All these 4 loops are touching to the first forward path, is it not? If any one of not touching to that forward path, then you will have some value for delta 1. Understood? So there are 4 individual loops are available in the given signal flow graph. All these individual loops are touching the first forward path. If it is the case, in this case, that delta 1 value is equal to 1. Okay, therefore, what is delta 1? Delta 1 equal to 1 here. Your delta 1 is nothing but 1 here, plus, okay, your delta 1 is equal to 1. And P2, what is P2? P2 nothing but your second forward path with its path gain. What is that? G1, G2, it is G1, G2, G6, G5. G6, G5, that is your second forward path, P2. So the P2 value is this much only. From the first step, from the step 1, you have identified P2 is equal to this. Then what is delta 2? Delta 2 is nothing but, it is the value of delta with respect to the path 2. Again the same as we have explained for this particular P1 delta 1. In this case also, for this also, it will be like that only. That means that for the available individual loops of the given signal flow graph diagram, if any one of the individual loop, if it is not touching to the second forward path, then you will get some value of delta, that is nothing but delta 2. Okay, otherwise, if all the individual loops which are available, which are there in the signal flow graph, given signal flow graph problem, and if all those loops are touching to the second forward path, in that case, again delta 2 becomes 1. Means, if you consider your second forward path, okay, from node 3 to node 5, actually, if you see your problem, from node 3 to node 5, you have the second forward path actually. At node 3, between node 2 to node 3, you have one first loop. This first loop is touching to the second forward path. Okay, second forward. Therefore, for the second forward path also, all these loops are touching. Is it not? So, between node 2 to 3, you have the first loop, and this loop is touching to the second forward path at node number 3. Is it not? Again, the second loop is starting between node 3 to 4, and again at 3 for the second loop at node number 3, this path is touching. And consider the third loop, and for the third loop which is there between node number 4 to node number 5, at node number 5 the second forward path is touching here. That means that all these loops which are available in this are touching to second forward path. Therefore, all the loops are touching, therefore the value of delta 2 is also equal to 1. Therefore, it is 1. This is what your this thing. Then what is the delta? What is the delta? Delta is nothing but, I already explained in our previous session that, I am erasing this. What is delta? How to find out the value of delta? Delta is equal to, it is 1 minus sum of gain of individual loops, that is nothing but L1 plus L2. Directly I will write. Why all the time theory is required? It is not required, no? So that you will. So this means that this is as per the formula, that the formula for delta is equal to 1 minus sum of gain of individual loops. Means how many individual loops you have? 4 loops. Means you have to combine all them. You sum up. Means L1 plus L2 plus L3 plus L4. So it is there minus, and then now the second term comes plus. Then here what we have seen? Here the sum of product of gain of all possible combinations of two non-touching loops. So you have one two non-touching loop, means you have one combination that you have considered as L11. That's all. Now simplify, substitute all known values here. What is L1? What is L2? What is L3? That is G2H1. G2H1 plus what is L2? G3H2. What is L3? G4H3. What is L4? G6 H2 into H3 plus what is your L11? L11 nothing but G2H1 and G4H3. G2H1 G4H3. This is what your delta. Now substitute in your transfer function. Finally you will have transfer function is equal to, what is the, simply as nothing but your P1 plus P2. That's all, because delta 1 delta 2 values are 1 only. That's why not required to write. Actually P1 delta 1 plus P2 delta 2 by delta basically. So as your delta 1 delta 2 became 1, therefore you write P1 plus P2 by delta. What is P1? P1 is nothing but G1, G2, G3, G4, G5 plus what is P2? G1, G2, is it not? G6 and G5. This is your P2. Okay. put in a bracket and take by what is means? Actually 1 minus, as I have seen, as I have explained in the previous step, it is 1 minus, therefore your if you expand that, it is 1 minus, what is that? 1 minus G2H1 minus means L1, this is nothing but your L1, is it not? G2H1 G3H2, this is L2 basically, and then L3 G4H3, this is your L3, and what is L4? G6H2 G6H2H3, is it not? And plus what is L11? G2G4, I can write like this. What is that? G2G4 H1H3. This is what your transfer function. This is what your transfer function now. This is what your transfer function. This is what the answer, right? So with this example, I would like to conclude this session, and we will see some more examples in the subsequent session. I think you are following, and I think that you are understanding these concepts, and request you all to comment on this and to give your feedbacks, and you please share to your friends also, so that everybody will be benefited from this. Thank you one and all.